all tried battle flipping. That satisfying moment when it lands upright. But have you ever thought about the science behind it? Today, we'll explore how battle flipping actually demonstrate projectile motion. When you flip a battle, you're launching it through the air like a projectile. That means it moves in a curved path because two forces are acting on it. The force you apply when you throw it and gravity pulling it downward. Your throw gives the battle its forward and upward motion, while gravity constantly pulls it back down. Together, they create the smooth arc-shaped motion we call projectile motion. Now let's talk about the spin. When you flick your wrist, the battle rotates around the center of mass. That's the exact point where all the weight seems to balance. The position of the water inside the paddle affects this balance. If the paddle is filled about 1/3 with water, the center of the mass moves lower. This gives the paddle more stability, making it easier to land upright. But if there's too much water, it becomes heavy and hard to rotate smoothly. If there's too little, it spins too fast and loses control. So, the secret to the perfect flip is finding the right amount of water. Not too full, not too empty. Just enough to help the battle rotate once and land with balance. As the paddle flies, the water moves inside, slightly slowing back the rotation. When gravity pulls it back to the ground, the paddle's motion steadies. And if the timing and spin are just right, it lands perfectly upright. Now let's take a look at the illustration of water bottle flipping. So for the example of the illustration, we have no idea why Mike Senatori's bottle flip has become an internet sensation. But we can explain the physics of the stunt. So Senatori says he prefers a 16.9-ounce water bottle with an hourglass-like shape. You can just grab any bottle. Nope. Mike, the guy who made this famous, used a 16.9-ounce water bottle filled with about 1/3 full. Why? Because that's a sweet spot. Too much water and it's a clumsy penguin. Too little and it's a flying missile. 1/3 give you definitely the balance. When you flip it, you're giving it angular momentum. That's just a fancy way of saying it spins. But here's the twist. The water doesn't spin inside with the battle. It slushes around. So instead of spinning wildly like a helicopter, the water's movement slows the spin down. It's like when you're dizzy after spinning too much but your friend, the water says, "Relax, I got you," and helps you steady yourself. As the bottle spins, the water moves towards the bottom, lowering the center of mass. That's the point where all the weight balances. The lower it goes, the more stable the bottle becomes when it lands. It's like the water's whispering, "Don't worry, I handle the landing." And it's like when you're jumping off a jeepney and try to land gracefully, you bend your knees to balance, right? That's what the water's doing for the bottle. Finally, gravity takes over. And if the bottle spins is low enough and its center of mass is low, boom! It lands perfectly upright and you feel like you just won a Nobel Prize in physics. But if it fails, which happens a lot, remember, even gravity has a sense of humor. So every time you flip a bottle, you're not just playing, you're using physics. The curve you see is a projectile motion. The spin gives it stability and the water's balance helps it stand tall. So, what did we just learn? Bottle flipping is a mix of projectile motion, the flight path, angular momentum, the spin, and center of gravity, the balance. It's science in action. Fun, frustrating, and surprisingly educational. So, next time someone says bottle flipping is just luck, you can say, "Nope. It's physics, darling."